Today I'm going to show you how I created this character using traditional 3D techniques combined with a smart Figma Weave workflow. As you probably know, creating a 3D character can be both challenging and time-consuming. But with today's tools, I found a way to make the process much simpler, while also using AI to help with creative exploration and style development. Hi, I'm Nam, a 3D designer and an animator. And if you're a 3D artist like me and you enjoy combining advanced AI tools with your workflow without losing control over your 3D pipeline, this tutorial is for you. This is a slightly more advanced tutorial. If you want to learn more about getting started with 3D in Weave, I recommend watching Itai's tutorial first. You'll find the link in the description. Today we are going to cover 4 stages. 1. Using Weave to create a proxy model of our character. 2. Using Weave to explore different styles and ideas while keeping the original character design consistent. 3. Creating textures and material variation. And 4. Retopologizing the model and rendering it in your preferred 3D software. First, we start with the character design. I sketched the character myself using Procreate on my iPad, but you can use any sketching tool you prefer. For the 3D development stage, we need a character to be symmetrical and placed in either a T-pose or an A-pose. My original design has the personality and shapes I want, but it isn't suitable for 3D generations yet. Instead of spending time redrawing everything manually, I used Nano Banana to prepare it for the next stages. I asked it to transform the original character into a clean, symmetrical T-pose, while keeping the design the same. The shapes, the proportion, the hands, overall personality are still the same. Next, I used several 3D model generators to create the initial mesh. I like to compare results from different models so I can choose the best possible starting point. In this case, Meshi gave me the strongest result, so I'm going to work with that. To make this model production ready, we need to retopologize it. One trick I like to use at this stage is generating a topology reference with an image model. You might be surprised by how useful the result can be. Instead of spending a lot of time playing the topology from scratch, I can use the generated image as a visual guide. This saves me time and allows me to focus more on the creative and artistic parts of the process. After a quick retopology session, it's time to start working on the textures. I prepare my canvas and I use Weave's new color palette node to define the color scheme I want. It helps me to keep the entire design visually consistent. Next, I need to decide what the textures should look like. To do this, I combine the original character design and the color palette with a list of different materials. My list includes materials such as glass, leather, resin, ceramic, wood, polymer clay, cardboard, felt, fleece, fabric, and much more. I created this list using a prompt and an array node, and I can easily add or remove materials whenever I want. Together, the character, the palette, and the list creates what I like to think of as a small rendering machine. It lets me generate the same character with many different materials while keeping the original design and color palette the same. I can see what a character might look like in polymer clay, cardboard, paper, porcelain, fabric, glass, and felt. I can also run the same material several times to explore different color distributions and compositions. Maybe I like the head from one version, the dress from another, and the face color from the third. Instead of endlessly changing colors and materials inside my 3D software, I can quickly explore these options and build a much clearer version for the final character, extracting a PBR material from a reference. Once I'm happy with the visual direction, I want to turn the reference into an actual texture I can use in 3D. Now, this is where the real magic happens, so pay attention. I'm going to connect my image, the one that I want to extract the texture from, into this workflow. And here you can see I'm using a painter node. What I'm going to do is that I'm going to mark the area I want to extract. In this case, I want to extract the felt material, but I need to describe it. And I don't want to do it manually, because I might not be able to describe it well. So I'm connecting it to an NELM. The NELM here, which I named Material Description, has a guidance. The prompt is to describe the material marked in red. Describe the material property for texture creation later. And you can see, whatever I will mark in red, once I run the NELM, it will give us a description. So this is kind of perfect, because now we can use this description for this model. The model is patina extract, and what it does, it takes a description, and it will extract the material from the image. And what's happening here is that I can choose in the properties which kind of maps I want to extract. So base color, normal, roughness, metalness, height. So there are lots of ways to control the maps we are going to get. And you can see, this is my material, this is the output. You can see the felt material in the different maps. And the material that we got is exactly the same like the one from the image. And if we scroll here, you can see all the maps. We got a normal map, roughness, metal map, base color, height map, so we've got everything we need. Now we can just use this and plug it into whatever 3D software we like. And we get the same texture, and it's tileable, which is amazing. I can run this again by marking another part of the image, and we will get another texture, another set of maps. So we can just immediately download this, and we have this felt texture, a new PBR. And it's original, it's new, and it's based on what I wanted. This one technique has completely changed the way I work with materials, and it's all done using tools inside of Weave. Before moving into my 3D software and building the final shader, I like to previs the result. So what I do, I use an image model to generate rendered previews of the texture, allowing me to see how the material reacts to different lights and conditions. This gives me a much clearer idea of how the final result will look. It also saves me from spending too much time endlessly adjusting and fine-tuning shader nodes. Another thing Weave is especially good at is iteration. Once the workflow is built, I can easily test a completely different direction. All I have to do is connect a new texture to the workflow, and that's it. Using this workflow and the techniques I've shared with you in this tutorial, you can create endless texture variation, explore different visual ideas in seconds, and save hours of work. If you like this workflow and you want to try it yourself, you can duplicate the full setup and start using it right away. You will find the link attached in the description below. Bringing Weave into my 3D workflow honestly feels a little like magic. It allows me to work with 3D in a way that feels much closer to sketching, more playful, flexible, and experimental. At the same time, it helps me to achieve stronger results through the process that is much faster and simpler. That's it for today. I was Nam, and let me know which workflows you would like to see next.